So, one of the basic algebraic skills that can get pretty tough for kids is trying to solve for a variable that's in an exponent in a fraction. So, a good way to get better at this skill is to take an example of a logistic growth equation that we're learning this week. So, let's see how we can solve for R when all other variables are given. A population reaches a final population over time of 110 from an initial population, P naught, of 16 over a time of 19 days. That's our T. The carrying capacity, K, is 290. What is the R? So we could even just really ignore what the meaning of these variables are, and we're just solving for an unknown. So here's the basic formal way of writing a logistic growth equation. There's others, but this is the one that we're using here. So when we plug in the variables, the one value that we don't know is R, and this can be pretty knotty to solve for if we don't have a ton of algebraic experience, because it's in a fraction and it's in the denominator of a fraction as part of an overall equation. So the way that we solve this is through a successive collapsing of the equation to make it simpler, and then gradually move all of our values away from the side that R is on. Now, I could have written this in even more detail, but this is a pretty basic way of multi-stepping a solution of this type. So we now can take the initial plug-in and see that there's a couple of values that can be resolved instantly. The numerator in this fraction, of course, it's simple multiplication, and then the subtraction part that's embedded in a parenthesis. So we do that here. You can see now that we've already made this equation significantly simpler. I forgot to leave a little bracket here, okay? From there, what we need to do is get rid of the fraction aspect of this problem and put everything essentially on a numerical line with each other. And so we do that by simply multiplying this side by the denominator, which isolates that side. From there, we've got a little bit more simplification that we can do to start getting things over from the R side or the unknown side to the known side before we need to address how to take care of Euler's number. So because this is a multiplication against everything that's in this bracket, we can simply divide it over and make this a denominator divided into 4640, and we get this as our simplification. From there, we now have this entire expression uncovered, and this 16 we can get rid of simply by subtracting it into the other side. 42.2 minus 16 is 26.2. So as we can see, we're about to see daylight here. We've got one more value that we can move over to the known side before we tackle Euler's number and the exponent by dividing 234 into 26.2, giving us 0.112, and on the other side, Euler's number raised to the negative of our rate times the time of 19 days. So at this point, we bring in the natural log, which performs two tasks to solve our problem finally. The first task is that it is the inverse of Euler's number, so it cancels out Euler's into 1. And the second thing that it does is that it brings down the exponent and on the same level with our standard numbers. Now what we do to one side, we must do to the other, so we take the natural log of this side, and we have negative 0.219, and on the other side we have negative R times 19. The negatives, of course, can cancel, so everything becomes positive, and then finally we take 2.19 divided by 19, the remaining thing left on the unknown side, and we have a growth constant of 0.115 for this logistic growth equation. So in summary, when you have a problem of this type, Like so much in algebra, we want to simplify what is collapsible inside parentheses or our operations that aren't tied to other parts of operations. And then from there, we do the old algebraic concept of moving things over from the unknown side to the known side to isolate eventually our variable.